It feels like everyone's doing their own Chromium wrappers nowadays, from my search engine DuckDuckGo to Microsoft with Edge to Perplexity with whatever the heck's going on with Comet to my friends over at APuntNet building Helium. But what about OpenAI? Atlas is definitely a Chromium wrapper, right? Well, it is, and it's also something much scarier. I just read and dove deep on Owl, which is their new architecture for the ChatGPT-based browser, Atlas. I filmed a different intro a couple minutes ago, before I had read this article. I saw demons. This was a terrifying read. It's really cool that they shared all of this architecture, but being that I've spent as much time in Electron and Chromium as I have in the past, this one scared me. So if you like big technical deep dives and or watching me spiral into chaos and depression, you're probably going to enjoy this video a lot. This has everything you don't want, from chaotic rewrites of things that shouldn't be touched, to retranslating events in many different directions from higher level to lower level and back again, to me just getting stressed and angry. This one was a journey, and I hope you enjoy it as much as I didn't. All of that said, I'm going to need therapy after this one, so let's do a quick word from today's sponsor so I can afford it. Are you tired of waiting on builds? Then you'll love today's sponsor, Depot. These guys will take your builds, your CI, and everything else that you're dealing with on GitHub Actions and make it way, way faster, especially those Docker builds. Previously, I was talking about this based on the testimonials that they had and the cool things I'd looked into when I played with it on the side, but now I have an actual story to tell you guys. As y'all know, I switch browsers a good bit, but I've settled on two. You're seeing one of them right here, Zen, but the one I use for my day-to-day tends to be Helium because I need a browser that has Chromium stuff. Chromium just makes my life much easier. Helium is built by two kids that are working their butts off to make a better browser that is a fork of Chromium. That is not easy to maintain, much less build. And before they made the switch to Depot, their builds were 40 plus hours long. Now they're under 7 for all platforms, and they were also able to roll out to Mac and Linux much smoother as a result of moving to Depot. So it's got to be super expensive, right? It actually ends up being way cheaper. Not only is Depot going to make your actions literally 5 to 50 times faster in some scenarios, they're also going to make the build cheaper in the end. It's one of those things that's just such a no-brainer. I don't know why people aren't trying it. You can take my word for it or read all the other stories, from how PostHog cut their build times by 55x, how Jane cut their GitHub action costs in half and increased throughput by 25%, or the crazy stories I just told about Helium. Your engineers are too expensive to be sitting around waiting for builds all day. Solve them now at soydev.link/depot. Oh boy, it's been a bit since I got to dig deep on Chromium stuff. I'm actually really excited for this. So let's dive in. How we built OWL, the new architecture behind our ChatGPT-based browser, Atlas. I like they're saying ChatGPT-based and not Chromium-based, but sure, we'll go with it. Last week, we launched ChatGPT Atlas, which is a new way to browse the web with ChatGPT by your side. In addition to being a fully featured web browser, Atlas offers a glimpse into the future, a world where you can bring ChatGPT with you across the internet to ask questions, make suggestions, and complete tasks for you. In this post, we unpack one of the most complex engineering aspects of the product, how we turn ChatGPT into a browser that gets more useful as you go. You mean how you added ChatGPT to Chromium? Sure, but I think the end side will be worth it, as cringe as this intro is. Making ChatGPT a true co-pilot for the web meant reimagining the entire architecture of a browser, separating Atlas from the Chromium runtime. This entailed developing a new way of integrating Chromium that allows us to deliver on our product goals, instant startup, responsiveness even as you open more tabs, and creating a strong foundation for agentic use cases. Shaping the foundation. Chromium was a natural building block. It provides a state-of-the-art web engine with a robust security model, established performance credentials, and peerless web compatibility. Furthermore, it's developed by a global community that continuously improves it. It's a common go-to for modern desktop web browsers. I like they said it's developed by a global community and are intentionally just like not mentioning Google anywhere in here. Very fun. Like Google is the main entity driving this development. There are people all around the world contributing to Chromium, but 98% of the work is coming from Google employees. The amount of public free work that Google is paying for Chromium is something they deserve a little more respect for. I get everybody thinks that Google's trying to own the web. They don't have to make Chromium open source. They don't have to contribute millions of dollars a month to its development, but they do because they want the web to win as much as they want to win themselves. Rethinking the browser experience with a sidebar for chatting. Our talented design team has ambitious goals for our new user experience, including rich animations and visual effects for features like agent mode. This required our engineering team to leverage the most modern native frameworks for our UI. SwiftUI, AppKit, and Metal, instead of simply reskinning the open source Chromium UX. Fun. I like that all of the modern native frameworks for UI are Apple here. Is it still Apple only? Pretty sure it's Mac only, right? Yeah, download for Mac OS. It's still Mac only. Fun. Knowing that they built this so heavily in with SwiftUI, AppKit, and Metal, I wish them luck. SwiftUI barely works on Mac OS. I cannot fathom trying to get that working well in Windows. I honestly think the big bet that browser company made on trying to make SwiftUI work for the browser is a big part of why the Windows project failed, and probably a big part of why they lost motivation to maintain Arc entirely. SwiftUI should have been much better than it is. I talk to a lot of iOS people, and there's a varied opinion on SwiftUI. A lot of people who love it, and a lot more that want to love it and are just burnt by all of the churn and changes and performance issues. You're getting a lot of the problems that you get from React Native when you move to SwiftUI, which is a crazy thing to say because it was meant to kill React Native, but it is what it is. But they still are using AppKit as well in parallel, which is kind of crazy. And then Metal's called out, which is the lower level rendering engine, similar to like a DirectX type thing for Macs and iOS. This is a weird set of things to mention here, but yeah, that means they're building a lot of native code for their apps. And it means that these things are going to be much harder to get onto other platforms. So if you're sitting around here waiting for Atlas to come to Windows, good luck. I'm sure they're running a codex job in the background trying to port all this code over to random .NET shit, and I'm sure that's going about as well as you would expect. But yeah, I am very happy with Helium right now, which is my Chromium-based browser by my friends over at Imputnet. Very, very nice browser. They're customizing the hell out of Chromium, but they're not doing this with Swift and SwiftUI. They're doing this with C and C++, the way the original Chromium codebase does. Well, to be more accurate, they're doing it with patch files. It does look like they're automating a lot of the patching now with Python, which is cool. But a significant portion of this codebase is patch files. That's how they're doing the work. So they're not adding new languages or tech in. They are patching the existing stuff, which is very cool. And they're doing a great job with it. Helium has been incredibly well maintained. Highly recommended if you're looking for a Chromium-based browser. Yeah. Anyways, they had other goals like fast startup times and supporting hundreds of tabs without penalizing performance. These goals were challenging to achieve with Chromium out of the box, which is opinionated about many details from the boot sequence, threading models, and tab models. We considered making substantial changes here. We wanted to keep our set of patches against Chromium targeted so that we could quickly integrate new versions. Interesting. So they're trying almost to like keep the Chromium part separate and light on patches. So when that changes, the amount of like integrations they're doing that has to change is less. They're definitely building this so that maintenance isn't that hard if they decide to not fully support it in the future, or if they want to iterate in different directions with it. The more they patch Chromium, the more they have to maintain the Chromium patches and the Chromium instance within this project. It makes a lot of sense to try and keep those separate, but it also results in the chaos of building your own separate UI on top of it with a handful of shims to break out. It'll be interesting to see how maintainable this is over time. I would be surprised if they didn't poach somebody from Arc or browser company to help with figuring out the architecture here. To ensure development velocity was maximally accelerated, we needed to come up with a different way to integrate and drive the Chromium runtime. A litmus test for our technical investment was not only that it would enable faster experimentation, iteration, and delivery of new features, but it would also enable us to maintain a core part of OpenAI's engineering culture, shipping on day one. Every new engineer makes and merges a small change in the afternoon of their first day. We needed to make sure this was possible, even though Chromium can take hours to check out and build. Yeah, Chromium is not a fast build process. Our solution, OWL. Our answer to these challenges was to build a new architecture layer that we call OWL, the OpenAI web layer. The OWL is our integration of Chromium, which entails running Chromium's browser process outside of the main Atlas app process. Oh boy. Oh boy. I have a lot of trauma around the Electron and Chromium IPC binding layer. Oh God. One of my old projects, my first like viral GitHub thing, is this template I made called Yerba, which was my best attempt to try and make a full stack type safe binding layer between Electron, the like Electron system code, and the actual client code, so you can call things between the two reasonably easily. I put a lot of work into this project and haven't touched it now for many years. But I've also heard people still using this as a reference or even a basis for their own projects using Electron. because getting that full stack type safety was obnoxious. I did this by grabbing this Electron file from the Electron side that is the type definitions that I bind to Windows so you have access to them, to try my best to force it to be type safe. Not easy or fun. I just remember this project being really annoying to build and maintain. Regardless, I've been through it with these things. Apparently, Egoist, who's one of my favorite devs, made a much, much more fleshed out version of this with TIPC, which is like TRPC, but for the IPC bindings in Electron. That's really cool. Also has not been maintained for a while. Yeah, we've both been through it with Electron. So I get trauma as soon as I see this part of this diagram. Anyways, think of it like this. Chromium revolutionized browsers by moving tabs into separate processes. We're taking that idea further by moving Chromium itself out of the main application process and into an isolated service layer. The shift unlocks a cascade of benefits. It is a simpler, modern app. Atlas is built almost entirely in SwiftUI and AppKit. One language, one tech stack, one clean code base. Oh boy. Oh boy. This is never coming to Windows. God. If they're specifically trying to have one clean code base and then they're building all this shit with SwiftUI and AppKit, this is never coming to Windows ever. And if it is, it's not going to move anymore. Oh boy. There's also faster startups because the Chromium engine can boot asynchronously in the background and Atlas doesn't have to wait. Pixels will hit the screen nearly instantly. Let's try. I'm pressing enter now. That was not that fast. For comparison, I'm going to close Helium and I'm pressing enter now. It was faster. Cool. Yeah, I'm going to call bullshit on that one. I'm sure it's faster than what they were doing before, which is booting their app, then booting Chromium. But yeah. Next piece is that it's isolated from the jank and crashes. Chromium is a powerful and complex web engine. If its main thread hangs, Atlas doesn't. If it crashes, Atlas will stay up. What are they doing to Chromium where the main thread is crashing? I need Waco's opinion on things. I wish he was here. I'll bug him later. Next piece is that there are fewer merge headaches. Because we're not building on as much of the Chromium open source UI, our diff against upstream Chromium is much smaller and easier to maintain. It's not slowing down Waco that much, but I get it. And then faster iteration. Most engineers never need to build Chromium locally. OWL ships internally as a pre-built binary, so Atlas builds take minutes instead of hours. Okay, that part is fair. If you're not touching the patch files, then you can have a cached entity that is this right side of the diagram so that you don't have to rebuild that when you're playing with this part. That part makes a lot of sense, and I can see why that'd be a lot faster. That said, good luck once that SwiftUI project gets big. SwiftUI's compile times are known for being really good and reasonable. Good luck. So how does this actually work? At a high level, the Atlas browser is the OWL client, and the Chromium browser process is the OWL host. They communicate over IPC, specifically Mojo. Oh man, I haven't been this deep in Chromium stuff in a minute. Oh god, this hurts. If you weren't familiar, Mojo is one of the ways that you can do IPC inside of Chromium to get things in and out of the backend processes. Backend means a very different thing here, but you get the idea. It's the part that is running in the C++ native layer. And you expose these by making a .mojom file, which has an interface definition. Getting header file vibes. This is a world I am so thankful to be out of at this point. Yeah, see the pingable.h, this is the header file that goes alongside the mojom file in order to bind things together and make this work. God, I hate all of this. I am so happy to be free of this world. So these are all communicating over Mojo, which is Chromium's message passing system. They wrote custom Swift and even TypeScript bindings for Mojo, so the Swift app can call host-side interfaces directly. Yep. I would be curious to see how the TypeScript definitions there work. That's got to be painful. The OWL client library exposes a simple public Swift API, which abstracts several key concepts exposed by the host's service layer. The session, which allows you to configure and control the host globally. The profile, which lets you manage the browser state for specific user profiles. Web view, which allows for controlling and embedding individual web contents like render, input, navigate, zoom, etc. The web content render, which allows you to forward input events into Chromium's rendering pipeline and receive feedback. So if somebody clicks something inside of your Swift UI layer and you want to pass that down to one of the renderer processes, this lets you do that. And then the layer, host, and client layers, which exchange compositing information between the UI and Chromium. God, I This was not as vibe coded as I thought. Terrifying. I do have a friend and active chatter hanging out here, NMG, saying there's a whole lot that they wish they could say but can't. Let me drop my suspicions about the potential security holes that my friends in chat may or may not have found already. I suspect that by exposing many more things over Mojo, in particular via TypeScript, that there are now things that are exposed in the client layer, as in the client that is rendering your JavaScript, that might not have been intended, which would hypothetically allow for someone from JavaScript to execute things on that native host layer by calling the bindings. Am I on to something here, NMG? Yes, no, or can't say are all good answers. Okay, it's not that special. Okay. I'm thinking I'm going to 200 IQ for somebody that's 50 IQ in the space. Good to know. Anyways, more diagramming of how this is broken up. We have the web view in Swift and the Mojo IPC bindings handle things like navigate, stop, reload, all going to the OWL process, which is the web view host in C++. And this is how they go back and forth between them. Fun. There's also a wide range of service endpoints for managing high-level features like bookmarks, downloads, extensions, and autofill. They had to re-implement everything for this then, huh? I thought this was a much more minimal Chromium wrapper than it is. Yeah, I just looking at this now, it's silly, but like the way the tab bar works, this isn't a Chromium tab bar. I fell for this. I thought this was much more minimal a Chromium wrapper than it is. Yeah, that the way that like open tab moves is something that no one would bother doing with the C++ code. It's also why the settings page is entirely different. This broken out dialog for settings is not something that would exist in the standard Chromium browser. Very interesting. Very interesting. They might have put more work in here than we thought before. Oh yeah, that is such a SwiftUI text box. That is such a SwiftUI text box. The cursor being right at the start of the filler text that wasn't removed properly because that's not a default behavior for inputs in SwiftUI for some fucking reason. Yeah, this is SwiftUI for sure. Cool. So how do they actually get the pixels across the boundary? Because that's the interesting thing. If the WebView host OWL process, like the actual Chromium part, is doing the rendering of the page, how do they get that into the SwiftUI layer at all? There's no way they're just IPCing up all the pixels and data, right? Please tell me they're not doing that. Web views, which share a mutually exclusive presentation space in the client app, are swapped in and out of a shared compositing container. For example, a browser window often has a single shared container visible. Selecting a tab in the tab strip sways that tab's web view into the container. On the Chromium side, this container corresponds to a GFX accelerate widget binding, which is ultimately backed by a CA layer. We expose that layer's context ID to the client, where an NS view embeds it using the private CA layer host API. Okay, so they are passing the identifier for this container context up to the view where it can be rendered natively-ish. Interesting. Oh God, select dropdowns render in a separate layer. Oh God. Their solution for that is interesting. They don't have a content : web contents, but they do have content : render widget host view with their own accelerated widget. So the same delegated rendering model applies. God. But now they have to conditionally, when you open up a select tag on a page, change which parts are being rendered through this pipe. Apparently they're using a private API for this. Definitely not a thing that can go wrong. Oh God. Oh God. I have a feeling that this approach they have taken is going to cause more problems for maintenance over time rather than less. Because if any changes happen to how this accelerated widget pipe works, or how they hoist things through this, there's a layer in the browser now. I forgot the term for it. There we go. That's the thing I was thinking of. And of course, Jay Hayes, the writer here. Yeah. The top layer is this new layer they're putting in as part of full screen API to handle things like dialogue support and all of that higher up above. So you don't need all of these crazy packages to manage tooltips that don't break due to overflow rules. It's a very annoying layer. And that's a change that they have been working on for a while. That article was 2022, and these things are still rolling out. Chromium doesn't really care about breaking changes in how things work internally because they'll eat it. They'll just pay the cost and rewrite entire layers of Chromium, and most people will never notice. Atlas is absolutely going to notice because if they change how that top layer works, good luck with your bindings. Owl internally keeps view geometry in sync with the Chromium side, so the GPU compositor can be updated accordingly and can always produce layer contents of the correct size and device scale. The fact that they're even calling this out suggests that it didn't do that before, and different device scales and text rendering was breaking things. And once again, I will say, good luck making this work on Windows, where the text scaling is more a vague suggestion than an actual spec. Oh god, I do not envy whatever engineers have been tasked on making this work in Windows somehow, because I know there's a team in there working on it that's convinced they can do it and is suffering immensely. We also reuse this technique to selectively project elements of Chromium's own native views UI into Atlas. This is also useful for bootstrapping features like permission prompts quickly without building replacements from scratch in Swift UI. That's fun, that they have to project Chrome views in for certain things. This technique borrows heavily from Chromium's existing infrastructure for installable web apps on macOS. Oh man, not the PWA and installable Chromium app stuff. They're not even maintaining that anymore. Google's fully deprecated installable Chrome apps outside of Chrome OS. So whatever stuff you're borrowing here is unmaintained and is going to cause problems in the near future, almost certainly. God, I wish them luck with that. This is a very complex project that's going to have a lot of maintenance issues in the future if I understand anything about Chrome. Let's talk about how they handle input events. This is going to scare me. Cracking and forwarding. The Chromium UI translates platform events like a macOS NS event, so like things happening in the mouse layer, for example. They'll translate those into Blink's web input event model before they get forwarded to the renderers. So the renderers in Chromium don't know anything about how macOS handles inputs. They have a layer above that does that before it gets passed over. But since Owl runs Chromium in a hidden process, they have to do that translation themselves in the Swift client library and then forward the translated events down to Chromium. Oh god. The scientists were so enthralled by whether or not they could that they never stopped to ask, how fucking hellish will this be to maintain and port to Windows? God, can you see how red my face is getting? This is stressing me out. I don't know if you guys know this, but I built a big Electron app when I was at Twitch. We were doing Twitch Studio. We were trying to build an OBS alternative from scratch in Electron. I've seen the skeletons in these closets. They are horrifying. There are far too many, they are choosing to make this harder than we did, and we were trying to build a video rasterization pipeline with JavaScript bindings. I do not envy any of the people who have to work on this. I respect you, but I do not envy you. God, this hurts. Every single event that can happen in this higher level, be it a mouse event, a key, a copy paste, a screen reader request. Does this even work with screen readers? I don't have one set up on this machine right now. I usually keep a machine that's set up with like a ton of accessibility tools just for testing my own services. I don't have one right now because I wiped my other machine to give it to an employee. I would be very impressed if this doesn't break accessibility immensely. Once they have this forwarding layer built, they follow the same lifecycle that real input events would normally follow for web content. That includes having events returned back to the client whenever a page indicates that it didn't handle the event. When this happens, we resynthesize an NS event and give the rest of the app a chance to handle the input. Are you kidding? Are you kidding? Okay. Let's diagram what they just described there, because this hurts me. So let's say you have a macOS app, which obviously is a white square. And then you click something in it. Now, when this happens in the macOS app processes this as an NS event. What's actually happening, if we were to split this up a bit more, is macOS itself is the layer that receives the click and effectively translates this IO, this behavior, this thing, into an NS event click. So the IO thing that occurred, which is the click that happened and was processed by macOS, gets turned into this NS event that gets sent to your macOS app, in this case, in Swift. Could be whatever. You get the idea. We have this event, but this type of event isn't something that the Chromium process can handle. I'm also going to make these solid because they're actual things, and this process we're talking about here is more, I don't know how to describe it, but I think that the spaced out lines here, the dashes, will do a good enough job of it for me. I know that there are events that are much deeper in this pipeline, NMG, but we never translate down, we only translate up, which is what makes this terrifying. Apparently the screen reader does seem to work, which is good. But yeah, where this gets scary isn't the layering here, where the NS event gets translated by that macOS app in the Swift code over to be a web event, web input event to be specific. Where things get scary is if this web input event does not have what it's supposed to. So if you're clicking on something that's in the app and the browser process refuses it because you're clicking somewhere where there isn't anything. If I have some text selected and I right click on it, the web page might have a hijack for right click and it has to handle that. The web page might also almost certainly not have that. So now we have to do that event. So if it's a left click and the page handles it, cool, the page handled it. If it's something else and the page doesn't handle it, we need to figure out what we were supposed to do, which means we have to send it back to our app as a retranslated NS event. So what ends up happening if you were to do a right click on a page that doesn't have a binding for it is we send the click event to the macOS app. The event is translated into a web input event that is sent to the web page. And if the web page doesn't respond, then there is code there now. I don't even know where that fucking code would live at this point. That sends back a, hey, we didn't use this, which forces it to be retranslated back to an NS event because they never sent the NS event down in the first place. They just sent the web input event. So they have to recreate a fake synthetic NS event once it has that and it isn't hitting an event in the browser. That's Jesus fucking Christ. When the event is returned, they have to resynthesize an NS event and give the rest of the app a chance to handle the input. So to be even more fun here with this diagram, this retranslated event isn't retranslated yet. It's a rejected event. And once that rejected event comes in, it gets piped back in as a retranslated NS event. God. I don't envy the work that they have to do for all this. Oh God, agent mode. I've been so distracted by the Chromium side. I didn't even think about what happens when you let the agents control things too, and how absurdly complex those bindings must be, and how all of those are certainly written in Swift, which is going to make it impossible to run anywhere else. Oh boy. Atlas's agentic browsing features pose some unique challenges for our approaches to rendering, input event forwarding, and data storage. Our computer use model expects a single image of the screen as an input, but some UI elements, like a select dropdown, render outside of the tab's bounds in separate windows. In agent mode, we have to composite those pop-ups back into the main page image at the corresponding and correct coordinates so the model sees the full context in one frame. Do you understand what that means? They had to reverse engineer how macOS renders these layers to fake it in a screenshotable layer so that it will make a synthetic image of what the user would be seeing so that the computer use model can go do the right thing. Fucking Christ. For input, we apply the same principle. Agent-generated events are routed directly to the renderer, never through the privileged browser layer. That preserves the sandbox boundary even under automated control. For example, we don't want this class of event to synthesize keyboard shortcuts that make the browser do things unrelated to the web content being shown. That kind of makes sense, because again, the events only become like OS or browser events if the Chromium process rejects them. So they just have a short circuit here where that request comes back that checks, like, did an agent do this? And if the agent did this, it won't forward it back to a macOS command. But if the agent didn't do it, then it will. And I am sure there are no security holes in that implementation whatsoever. God, debugging this must be absolutely hellish. I see you like complexity, so I added complexity to your complexity. Agent browsing can also run in an ephemeral logged out context. Instead of sharing the user's existing incognito profile, which could leak state, we use Chromium's storage partition infrastructure to spin up isolated in-memory stores. Each agent session starts fresh, and when it ends, all cookies and site data are discarded. You can run multiple logged out agent sessions, each one in its own browser tab, and each fully isolated from the other. Yeah, that's not that hard or scary. It's one of the least scary things so far. Let's see the wrap up here. New way to use the web. None of this would be possible without the global Chromium community and their incredible work building a foundation for the modern web. Owl builds on that foundation in a new way, decoupling the engine from the app, blending a world-class web platform with modern native frameworks and unlocking a faster and more flexible architecture. By rethinking how a browser holds Chromium, we're creating space for new kinds of experiences. Smoother startups, richer UI, tighter integrations with the rest of the OS, with macOS, and a development loop that moves at the speed of ideas. That sounds like your kind of challenge. Check out the openings to work on Atlas for their software engineers for Atlas, iOS, and more. Oh boy. This was quite a read. I am pumped that they went this in depth on all of these things, even if it's giving me existential dread and anxiety thinking about all of the things that they've had to do here. God, I don't miss working in Chromium on these levels at all. I've said all I have to here. Chromium makes me scared. I don't want to talk about this any more than I have to, so I'm going to go. Thank you as always, nerds. Peace.